Leetcode problem 361 bomb enemy. Let's first try to understand the problem, and then we're gonna find a way to solve it. So we are given m times n matrix grid, and where its shell is either a wall W or an enemy E, or it is empty, represented by 0. So we're gonna return the maximum enemies you can kill using one bomb. So how the bomb can kill the enemies? So the bomb kills all the enemies in the same row and column from the planted point. So for example, if the bomb planted here, it's gonna bomb all the enemies in the same row and same column. Yeah, but there is a condition until it hits the wall, since it's too strong to be destroyed. Let's just check this example. So for this bomb, we can put it here. So top, we can go 1, go to the left, there's 1, go to the bottom side, there's 1, but go to the right side because of this wall is too strong to prevent it. So the bomb cannot bomb this enemy. So how many of them? It's gonna be 3. So we're gonna return the maximum enemies you can kill using one bomb. So it's gonna be 3 in this example. Now let's check the second example. We can put it anywhere, but at most we can bomb 1 enemy. So we're gonna return 1. Let's first check about the brute force idea. Yeah, so for the brute force idea is definitely we need to go through each row and each column, and we need to find the empty space, which is 0. So it's gonna be 500 times 500. Let me use another color, maybe it's better. Yeah, so it's gonna be 500 square to find the 0 cell, because we're gonna loop through each row and each each column, and we're gonna find the empty space. Yeah, so it's gonna be 500 square. Now, if we find, so for example, at one position, if we find it, so what are we gonna do? We're gonna go to the 4 directions. So what is the time complexity? It's gonna be 500 plus 500, right? Yeah. So what's gonna be the final time complexity? So 500 square, so it is 25 times 10 to the power of 4, and times this is 10 to the power of 3, 1000, right? Because this is 1000. So what's going to be the final time complexity? It's going to be 2.5 times 10 to the power of 8. Yeah, normally we should be careful about this kind of issue. So if it is like 2.5 times 10 to the power of 8, definitely it cannot pass for Leetcode. Maybe they just change the parameters. Before maybe it is just 100 we can pass. Now it becomes 500. Definitely we cannot pass because it is 10 to the power of 8. Yeah. Sometimes maybe 5 times 10 to the power of 7 maybe we can pass. But if it is like more than 10 to the power of 8, definitely we cannot pass. Yeah. But let's first use the brute force idea to check if we can solve it or not. Yeah. So let's go to the brute force idea. So let me just uncomment about those places, and let's just check the brute force. So we're gonna prepare a result. So we're gonna check each row and column, and I think I need to use this row and column. Let me provide where is my row and column. Yeah, it is here. Yeah. So the idea is that I'm going to use the row and column. It's going to be length of the grid and the length of the grid 0. And then I'm going to use the row and column. So I'm going to loop through it, and I'm going to check if it is equal to 0. So this means I find an empty space, and I'm going to use a result check. So the result going to be the maximum of result with check RC. And the check RC going to be here. And this is my check function. Yeah, let me just uncomment it. Yeah, so for the check function, this is going to be easy, and we just need to loop through 4 directions. So this is going to be for DRE minus 1 and 1, so this means go to the left and right, yeah, until, so this row is the next position, R plus DR. So if it is inside the boundary, and if it is equal to E, so the code would plus E to 1, because it is enemy, it is okay. But what if we find it is a wall, so we're going to break it. We're going to break the while loop, and we're going to check the next direction. So for example, the first direction is going to be left, and the next direction is going to be right. And similarly for here, so for DC, this is a column in up and bottom. Yeah. So we're gonna check the up first. If we find a wall, we're gonna break it, and then we're gonna check the bottom. If we find a wall, we're gonna break it, but we have a counter. Yeah. So the counter gonna accumulate all the 4 directions, and we get a final count. So this is for the row count, and this is for the column count. Yeah, I think this is okay. Let's just run it to check if it is okay. As you can see, it works, but let me submit it. Yeah, I think we need to wait for a little bit because it's gonna get time limit exceeded. Yeah, as I explained before, because it is 10 to the power of 8, normally Leetcode cannot pass such kind of testing cases. As you can see, we cannot pass the last testing case. So I think the last testing case is prepared the limit conditions. It means the row gonna be maybe 500 and column maybe 500, and inside it's gonna be a lot of zeros. Only with some places it may be E. So definitely we need to check all of them. Yeah. So this is why we cannot pass. It got a time limit exceeded. Now we will not use this brute force idea. So we're gonna use a new idea to solve it. Yeah. So the new idea is that while we are finding a place, so for example here, and then we go up, down, bottom, left, and right. Definitely we use the m plus n time. Yeah, this is the actual time. Before we have m times n time. Now we have actual m plus n time. But how can we reduce this m plus n time? Can we reduce it to O1? If we can reduce it to O1, basically OMN gonna work because it is just 500 times 500. Yeah, definitely it's gonna work. But how can we reduce it? So the easiest way, I mean, the coding is not easy, but the easiest way of seeking is maybe we're gonna use a prefix. We don't need to count all the up areas until we find a wall. We just need to use a prefix sum. So for the up, we're going to use a prefix sum. For the bottom, we're going to use a prefix sum. And for the left and right, we're going to use prefix sum. So this means for this position, we just need to use 4 positions. Yeah, up, left, bottom, and right. We just need to use 4 directions and 4 positions to get the final result. We don't need to use the actual m plus n time. We just need to use the time going to be 4. Only 4 directions at this position, at this position, at this position, at this position. We don't need to check all of them. So this is why it's going to be m times n time. We can reduce it. But if this is possible, it is possible by using the prefix sum. So let's just use one example. Maybe we're going to use up. Yeah. So if we are checking the up, so we're gonna yeah. Let me still use the red color. So for example, this one. Yeah. So for this one, we're gonna check the up. So for the up, we can use our prefix sum. So I'm gonna prepare padding for one row. This is gonna be easier for my coding to check. So for the first row, I'm gonna prepare padding, and for here, I'm gonna use the prefix sum. But this is only for up. This is gonna be 0, and this is gonna be 1 because there's a 1 enemy, and this is gonna be 0, and this is a 0. And then I'm gonna continue to use the prefix sum. As this is an enemy, this is gonna be 1. As this is a wall, it's gonna still be 0. And as this is an empty space, because currently I don't know whether I put a bomb here, but I'm gonna use the prefix sum. It's gonna be 1, and this is gonna be 1, and then this is gonna be 1, and this is gonna be 2, and this is gonna still be 0, and this is gonna be 1, because this is the prefix sum. Now I'm gonna use this bomb. I'm gonna check the up. So how many enemies for the up? There's 1. And similarly, I can calculate the bottom, left, and right, and I can get the final solution. So the only difficult part maybe we need to consider, if there is a wall, how should we deal with that? Yeah. If there is an empty space, how can we deal with that while using the prefix sum? So if there is an enemy, so we're gonna plus 1 while using the prefix sum. But while there is an empty space, what are we gonna do? And we just need to plus a 0 because empty space it is not an enemy. We just need to plus a 0. But what if there is a wall? We don't need to do anything. We just need to set it to be 0 because this is a wall. And for the next one, for example, while we are checking the right prefix, so for this one, this is 0. For the right prefix, it's gonna be 1. Yeah, we need to use 4 directions and 4 prefix sum, and then we just need to accumulate the 4 prefix sum to get the final result. Yeah. So let me just use my prefix sum idea to solve the problem. So let me uncomment the brute force code. Yeah, and let me start from here. Still, we're gonna use R and C, and we're gonna check it. So if it equal to 0, so we're gonna use the prefix sum to check. So here I prepared a check function. So now the check function, I'm gonna change it to the 4 directions. So this is gonna be my 4 directions: left, up, right, and down. And then I'm gonna prepare 4 prefix sum. Yeah, I didn't write it in one function. I think that's gonna be difficult to write, and it's really easy to make mistakes, and it's really difficult to debug. So I prepared 4 blocks to calculate the prefix. So first of all, let me use an example to explain the left, and after that I will not explain the right, up, and bottom, because basically it's the same idea. You just need to copy and paste the code and change a little bit to make it work. Yeah. Let me explain the left. So for the left side, we're going to prepare a DP array for the prefix sum array. As it is the left, I'm going to prepare a padding at the left side. So this is why 0 times c plus 1. For the first column, I'm going to prepare a padding. So the padding is going to be a 0 from the beginning, and everything inside is going to be 0, because if it is war, definitely it's going to be 0. So this is by default, I'm going to set it to be 0. Now I'm going to loop through each row and column. Yeah, so this is for all the rows, and this is for the column. But for the column, I'm going to start from the second row, from the second column, because the first column is padding. It is just to be zeros. Yeah, so I'm going to start from the second column, and because in this way I can easily use the prefix sum for the left. So the prefix sum for the left, let me use an arrow. It go to the right, but this is a prefix sum for the left. So for example, for this point, I'm gonna plus this one with this one. It's gonna be the left. Yeah. So I'm gonna check it. If grade R, C minus 1. So what is my C? C is 1. C 1 minus 1, it is 0. So if grade 0, 0 equal to E, so it means at this position. If it is an enemy, so what I'm gonna do? If it is an enemy, I'm gonna the left RC gonna be the previous one. It's gonna be RC minus 1 at this position plus 1, because if it is an enemy. But if it is a 0, it means it is empty space. So for example, this is a 0. It is empty space. What I'm gonna do? So the left RC is gonna be this position in my left prefix sum array. So it's gonna be left RC plus equal to left RC minus 1. RC minus 1 going to be 0 plus 0, so it's going to be 0. But for the next example, so for this one, if it is equal to E, so the left RC is going to be left RC minus 1, this one plus 1, because it is E. So for this position, it is going to become 1 while we are calculating the left prefix. Yeah, and similarly for the right prefix, and up prefix and bottom prefix, we calculated all of them. I think this idea is also used in a lot of Leetcode problems. Definitely the coding is too much, and it's really easy to make mistakes, but the idea is really clear. And in this way, we don't need to check if there is a wall, because we didn't check it. Actually, if there is a wall, it's going to be 0 by default. Yeah, if it is a 0 by default for the next one, for this person, if it is an enemy, next one, while we are checking the left array, it's going to be 1. So there will be no influence. We just set the walls to be 0, and everything should be okay. Yeah. Now, if you understand the left, basically you can write the right prefix, up prefix, and the down prefix. And finally, you just need to accumulate all of them. Because we prepared a padding, so we can directly use it. We don't need to check any edge cases. We just need to check the left, up, right, and bottom with RC, and we can get the final result. Yeah, now let me just run it to check. As you can see, it works. Now let me just submit it. As you can see, it's pretty fast, and it passed all testing cases, because currently the time complexity is m times n. And this check function, it should be okay, but here you need to write basically 4 prefix sum, left, right, up, and down. And then you just need to use brute force to accumulate all of them. I think that's all for it. Thank you for watching. See you next time.